Hey guys, it's Miss Johnson and I'm here to bring you our notes for Unit 4 Learning Target 6. Today we are talking about the 3 different methods of solving quadratics. We have looked at the first 2 methods of solving quadratics and there is a third method that we're going to talk about further, but I just want to talk about when we would use these 3 and why it's important to have different methods of solving them and what their purpose serves. So the 3 different methods to solving quadratics are graphing, factoring, and then using the quadratic formula. So we have so far talked a lot about factoring and also about using the quadratic formula. There is a way that you can solve the quadratic by graphing it, which we're going to do a little bit more of later. But let's just talk about what the difference is between using some of these methods. All right, so let's look at an example here. I've got x squared plus 9x plus 20 is equal to 0. And I want to solve this in 2 different ways. I'm going to solve it by factoring, and then I'm also going to solve it by using the quadratic formula. So if I factor this, that means I'm setting up my factor x. I have a times c on the top, which is 20. My a value is 1, my b value is 9, my c value is 20. So I have 20 on the top and 9 on the bottom. The factors that I get here, or the 2 numbers that give me a product of 20 and a sum of 9 are 4 and 5. 4 times 5 is 20, 4 plus 5 is 9. So the other thing here is this is a quadratic that has a leading coefficient of 1, which is nice because then I can use the shortcut. So if I use the shortcut here, that means I'm looking at x plus 4 at times the quantity x plus 5 is equal to 0. I can go straight to those factored forms because my leading coefficient is 1. Then from there, that's where I split them and use the zero product property. So I have x plus 4 equals 0 and x plus 5 equals 0. And then I subtract the 4, get x equals negative 4, subtract the 5, and get x equals negative 5. Okay, so those are my 2 solutions there when I use the zero product property, when I factor them and use the zero product property. Now let's take a look at what would happen if I use the quadratic formula. So if I use the quadratic formula, I'm going to plug my a, b, and c into that equation. So I have x equals the opposite of b, that's negative 9, plus or minus the square root of b squared, 9 squared, minus 4 times a times c, which is 20. All over 2 times a, which is 1. So in this case, I end up with the opposite of 9. If I take care of underneath the radical first, that means I'm looking at plus or minus 9 squared is 81. 4 times 1 times 20 is 80, so subtract your 80, all divided by 2. 81 minus 80 is just 1, so that's x equals negative 9 plus or minus the square root of 1 all over 2. And the square root of 1 is just 1. So I have x equals negative 9 plus or minus 1 all over 2. So that splits into 2 pieces. That's x equals negative 9 plus 1 over 2, which is negative 8 over 2, which is negative 4. And then I also can split that into x equals negative 9 minus 1 over 2, which is negative 10 over 2, which is negative 5. So if you take a look at your 2 solutions, you get a negative 4 and a negative 5, which is the same thing you got by factoring. Okay, so we've talked a little bit about how factoring is pretty nice. Factoring allows us to, it's a little bit shorter of a process usually. The quadratic formula takes us a little bit longer. It's a little bit more steps. But the one thing about the quadratic formula is that the quadratic formula works every single time. So that's good. We're going to see a little example of that today. Let's try another one. So solve using factoring and solve using the quadratic formula. So in this one, I have x squared plus 10x minus 24. So if I factor that, I have an a value of 1, a b value of 10, and a c value of negative 24. So my top number in the factor x is negative 24. The bottom number in the factor x is a 10. And so then I look for 2 numbers that multiply to negative 24 and add to 10. Now 24 is tricky because there's a lot of pairs that give me 24. But the one that I want here, oh, nope, see, I even did that wrong. I want a positive 12 and a negative 2. 12 times negative 2 is negative 24. 12 minus 2 is 10. All right, so again, my A value is 1, which you have to consider in factoring as well. If your A value is not 1, you got to go through the whole box method where you take those GCFs out. Since my A value is 1, I can use those as my factors. So if my A value weren't 1, I'd have a few more steps involved here. But because it is 1, that is going to help me. So here are my two factors, and then I'm going to split them apart. I end up with x plus 12 equaling 0, x minus 2 equaling 0. Subtract your 12, I have x equals negative 12, add your 2, x equals 2. So there's that. There's my two solutions. Okay, so now let's hop over here and look at the quadratic formula. So in the quadratic formula, I'd have x equals the opposite of b, which is negative 10, plus or minus the square root of 10 squared minus 4 times a times negative 24 times c all over 2 times 1. Let's look underneath the radical. So my negative 10 on the outside, I have 100 plus, because I have a negative times a negative here, and then 4 times 24 is going to be 96, I believe. Yep, 96. So I just plugged that into my calculator quick. You're obviously welcome to do that as well. Putting those two together, 196, negative 10 plus or minus the square root of 196 all over 2. And then the square root of 196 is 14. So x equals negative 10 plus or minus 14 all over 2. When I split those off, I'm going to come off to the side here. I have x equals negative 10 plus 14 over 2. And x equals negative 10 minus 14 over 2. That's 4 over 2, which is 2. That's negative 24 over 2, which is negative 12. So if I look at my two solutions there, I've got 2 and negative 12, which is also negative 12 and 2 that I got using factoring. So the point here is that factoring and quadratic formula are going to give you the same solution, which is nice, and it just depends on which one you're more comfortable with. Okay, so you've heard me mention now that the quadratic formula is one that works all the time. There are some times that factoring doesn't work. We saw in the factoring unit that there are some expressions that are not factorable. So what happens when factoring doesn't work? If factoring doesn't work, then we have to use the quadratic formula. So let's take a look at number 3. We have 2x squared plus 3x minus 4. So if I'm going to try the factoring method, this is my a, this is my b, this is my c, I'd have a top number, a times c, of negative 8, and then a bottom number, the middle term, 3. If I think about the things that multiply to negative 8, I'm looking at negative 1 and 8, I'm looking at negative 2 and 4, I'm looking at 2 and negative 4, and I'm looking at 1 and negative 8. If I add all of these, that's a 7, that's a 2, that's a negative 2, and that's a negative 7. So the thing here is I'm looking for 3. None of these are 3, so then this is not factorable. All right, now, just because it's not factorable doesn't mean it doesn't have a solution in the quadratic formula. What it means is we have to use the quadratic formula. You can't use the factoring method because this is not factorable. So then I'm going to go ahead and use the quadratic formula here and see what happens. So I've got x equaling the opposite of b, that's negative 3, plus or minus the square root of, that's 3 squared minus 4 times 2 times negative 4, all divided by 2 times 2. Start under the radical. I have x equals negative 3 plus or minus the square root of 9. And then negative 4 times negative 4 is positive 16 times 2 is 32. So 9 plus 32 over 4. I can go ahead and do that 2 times 2. Then I continue on with this. X equals negative 3 plus or minus the square root of 41 divided by 4. And here's what happens, or here's what made this not factorable. Take a look at what's underneath your radical. You've got the square root of 41. Now 41 is not a perfect square. When I take the square root of 41 in my calculator, I get 6.4 there. So this is x equals -3 plus or minus 6.4, all divided by 4. And that's why this was not factorable. Okay, because 41 is not a perfect square. If 41 is not a perfect square, then that's perfect square. Since 41 is not a perfect square, that's why we couldn't factor here. So now I'm going to keep going. I'm going to carry on. I've got, split this apart. I've got x equals -3 plus 6.4 over 4, and x equals -3 minus 6.4 over 4. So then that gives me 3.4 over 4 and -9.4 over 4. And when I type those into my calculator, 3.4 over 4, 4 divided by 4 is 0.85. So that's 0.85 there. And then -9.4 divided by 4 is -2.35. So there's my two solutions there. Now, again, this was not a factorable thing, but that doesn't mean it didn't have a solution. It just means that we had to use the quadratic formula, and I had to see if I got solutions that way. Now, there is one more setting that we need to take a look at. What happens if we get a negative under the radical sign? When we get a negative under the radical sign, that means we have no real solution. There's imaginary solutions, but we're not going to do much with those right now. You'll learn more about those when you get to Algebra 2. But there is no real solution when you have a negative under the radical. So let's take a look at this one. So I've got 3x squared plus 2x plus 5. If I start by trying to factor, here's my a, here's my b, here's my c. I've got a top number of 15 and a bottom number of 2. And again, if I think about the things that multiply to give me 15, that's 1 and 15, 3 and 5, and that's it. That's all that gives me 15. If I add those, I get 16 and I get 8, and none of them give me a 2, which means this is not factorable. Okay, so I can't factor it, so let's go over to the quadratic formula and see what happens here. So if I plug this into the quadratic formula, I've got x equals -2 plus or minus the square root of 2 squared minus 4 times 3 times 5 all over 2 times 3. Start under the radical and see what happens. X equals -2 plus or minus, that's 4, minus 20 times 3 is going to be 60. I said that fast. I did 4 times 5 in my head, which is 20, and then 20 times 3 is 60. That's what I did there. Divided by 6. Now, take this, 4 minus 60, and I get a -56. Now, I want you to pull out your calculators right now. When you pull out your calculator and you do the square root of -56, your calculator better give you some sort of error. The square root of -56 is not a possible thing. There is no real solution. There's never a time that you can multiply a number by itself and get a negative result, because every negative times a negative gives you a positive. You don't ever get a negative result. So when you get to this point, this is where you have to quit, stop, and tell yourself there are no real solutions. Okay. So I couldn't factor it because it was not factorable, and now we know why it wasn't factorable, because it's actually not something that has real solutions. So then that's it. I'm done. No real solutions here, and you call it good. All right, that's going to take us to the end of our video today. We just really wanted to compare to you the two different methods that we've talked about solving quadratics. We are going to look more into graphing later. But for now, using the factoring or the quadratic formula. Now, it does not matter to me which method you choose. If it's able to be factored and you choose to factor it, go for it. If it's not factorable, then you have to try that quadratic formula, okay? But it does not matter to me. Some of you may just choose to use the quadratic formula every single time, and that's fine too. That works. So anyways, thanks for tuning in today, and I will catch you next time.